Welcome to visualizing the adaptive mesh refinement of hypersonic flow in SimCenter Star CCM Plus, the submission for the Flow Visualization Showcase at Aviation 2020. I'm Jeremy Hankey of Siemens Digital Industries Software. Let's get started. We'll first look at the time history of the adaptive mesh as a solution has arrived, starting from the baseline mesh, which will appear in a moment. We'll first look at the Mach number field and the mesh on the vehicle center line as it evolves through a solve. The AMR model on the fly splits cells based on the gradient criteria specified in order to get the shocks and wake features refined to the final mesh, which appears around 1,000 iterations. We can visualize what is happening by looking at the refinement level field, which shows the number of times that a cell has been split and refined for an analysis. If we look at the history, we can see that the wake and the shocks near the body get refined, and then as the solution progresses and converges, those shock and wake refinements progress out further and further to the far field. A numerical Schlieren of density gradient magnitude will allow us to see how the shocks progress near the body. As you can see, in the first few hundred iterations, the shock shape evolves, and then the mesh near the body doesn't change much after that. We'll now move on to looking at the final AMR mesh of the converged solution at 10 degrees angle of attack. We'll start by looking at the cell size on a plane section as it moves axially back along the body. You can very clearly see the black and blue cells that are refined for the shock along the route and off of the body, as well as green, yellow, and other split cells in the wake. Now it'll progress a little bit faster once it gets behind the body. Next, we'll reposition and take a look at a spanwise section that's going to come out to show the three-dimensional character. And this time we're showing the refinement level again, where you can clearly see the dark blue regions for the shock and the light blue regions for the wake. If we zoom into the stagnation region near the bow shock, we can see that this refinement continues even into the body-fitted prism layers, allowing a very good, sharp capturing of the shock, evident by looking at the Mach field, where we can see a very sharp demarcation line where that bow shock occurs. If we keep the Mach number field visible and zoom out, we can see the sharp capturing of the shock all the way out into the far field, as well as capturing of the wake. The shock can also be rendered three-dimensionally by looking at a volume rendering of the density gradient magnitude, where we can see features of the shock such as shocks from the wings and from the cockpit of the vehicle. A volume rendering can also be useful to look at the regions of high temperature air near the stagnation zone and underneath the body of the vehicle. Next, we'll move on to look at how adaptive mesh refinement can be used to adapt the mesh to a variety of conditions for an entire angle of attack sweep. Here we have the Mach number field shown in the upper left, the refinement level field in the upper right, the cell size in the bottom left. And as we scroll through the conditions, we can see that the mesh adapts and refines based on the shocks and wake structures for each angle of attack condition, thus allowing a valid mesh from a single coarse baseline mesh for any set of conditions. The objective of this work was to show the applicability of the AMR adaptive mesh refinement model in SimCenter Star CCM Plus to hypersonic shock and wake structures. Thank you for your time, and I hope you enjoyed it.